Hi, thanks for joining. Today we're going to talk about ESPRIT Release 3.1. Specifically, we're going to talk about the new functionality that we've included when it comes to mating, digitization of work offsets, and also the expansion of the snap capabilities. First, let's talk a little bit about mating. Mating allows the user to easily move fixtures and workpieces, so there's no more guessing values and typing them in as the position values, either for the translation or the rotation. We've included three types of mating: parallel, alignment, and centering, and I'll demonstrate these to you a little bit later on when we switch over to ESPRIT. Next, let's talk a little bit about digitization of work offsets. Bases are now valid input when digitizing the work offset position. Previously, only points were valid input. If you digitize on a planar face, and that planar face is normal to one of the global axes, meaning the X, Y, or Z, then the X, Y, or Z part shift will update accordingly, depending upon which global axis is normal. If none of the global axes are normal to your selected face, then ESPRIT will give you feedback in the form of an error message. If you select a cylindrical or a conical face, and the axis of the cylinder or the cone is parallel to one of the global axes, again, the X, Y, or Z part shift value will be updated accordingly. And of course, again, if you select an invalid cylinder or cone where the axis is not parallel to one of the global axes, you'll get feedback from ESPRIT in the form of an error message. Finally, let's talk a little bit about snap enhancements. So as I mentioned previously, we've actually enhanced the snap mode so you can snap on endpoints and midpoints directly on a solid edge without having to take the solid and smash it into geometry. And this functionality is available whenever you need a reference point as an input. So let's switch to ESPRIT and let's actually show you the functionality that I was talking about during the presentation. Now the file that I have here is the file that I started on another video, a previous video that I made. That video talks about the CAD data exchange update, the starting files, the inclusion of starting files, along with the update of the user interface. So if you're interested, you can go back and watch that particular video. But that's where we are at this particular point in programming. And if we take a look at the machine, you can see I have a machine imported already, and I have a fixture on that machine, but I have yet to mount my workpiece. So let's go ahead and choose my vise, and I'll go ahead and then choose my workpiece. And this is where I'm going to use the different types of mating. And as I mentioned, we actually have three different types of mating. We have parallel mating, we have alignment mating, and we have center mating. Let me just show you a few different of the mating types before we actually try to get this part where it needs to be. So you can see right now, if we look, and maybe it's better if I look at my front view, you can see if I were to, let me just exit out of here just for a second. If I were to open and close my jaws, you can see it seems like my Z value is good, but maybe my X and Y values need to be updated. Without mating, I would have to basically either know those values and type them in here for my translation, but mating is going to make it much easier. And as I mentioned, first we'll show you some of the different types of mating before I actually get the part exactly, or the workpiece I should say, exactly where I need it. Now, no matter what kind of mating you do, you're going to choose basically two faces. So for example, I can choose the face of the stock here, and perhaps the face of the jaw here. And in this case, I can go ahead and choose parallel. Now I click it once and nothing happens here because the two faces are actually parallel to each other already. So there's no movement. Now that's different than if I were to choose alignment. So if I choose alignment mating, you can see it actually aligns the two faces using this distance that I've input. So that's the big difference between alignment and parallel. So parallel will just ensure they're parallel, where alignment mating will actually align them together. Now this is, you might have noticed that I actually flipped my part around. That's because there's actually more than one valid solution to this particular mating. So if it's not exactly, if the workpiece isn't exactly in the position that I want it, I can click on that same mating type again, in this case alignment, and you can see it gives me the second solution where again, this face of the jaw and this face of the workpiece are perfectly aligned. Now for the mating that we want to do, I'm going to choose the bottom, and then I'm also going to choose this face of on my fixture, and we'll choose centering. And you can see if we go to, say, our top view, and we zoom in, that actually properly centered my workpiece in terms of my X and my Y. Now, the only thing I have to do here is move it up in Z, and we knew previously from me closing and opening those jaws that if the Z value is 0, that's exactly where I want the workpiece to be. And I can click OK. And then again, I can open and close the jaws, and you can see by using the mating, I'm very easily able to get the part exactly, or the workpiece exactly where I want it to be in terms of my fixture. And that can also be used for placing the fixture onto the machine as well. Now let's talk a little bit about that work offset and the digitization of faces when we're trying to input the part shift for and also the XYZ machine shift for my position of my work offset. So we'll go ahead and click on this icon, which previously only allowed us to select on points, but now we can actually select on solid faces. You can see right now my part shift XYZ is set to 0, 0, 0, and I'm going to select on this face here. This face is normal to the global Z. So when we select it, you should see that only the Z value in the part shift updates, and it does. Similarly, I'm going to select perhaps on this face, which is normal to the X, and you can see the X value updates. And then finally, if I select on this face, which is normal to the Y value updates. So very easy now to select on the different faces. Now I mentioned if you selected on a planar face that is not normal to any of the global axes, you'll get a message that the planar face is not aligned to the global axes. Now I mentioned that you can also select on cones or cylinders. In this particular case, I can click here and I can select on this cylindrical face. And you can see that it updates, it actually aligns in X and Y the work offset with the axis of that particular cylinder. And similarly, I can actually select, for example, this face here. Now, in this particular example, let's pretend like we wanted to put the work offset in this corner. Again, this would be hard to do without knowing the exact values, but we can actually very easily do that by appropriately selecting on a few faces. I'm going to select on that face to get my Y, or excuse me, my X. Then I'll select on this face to get to my Y. And then the Z was already valid but I can select it again because I selected this face. And you can see I can very easily get my work offset transformation, or excuse me, my work offset exactly where I want it. Click OK. Click OK again to validate there. Now finally, let's talk a little bit about the snap enhancements. As I mentioned, you now have the ability of using the endpoint or in the midpoint of an edge of a solid, and you can use that at any time when you need some kind of point input. You may have noticed that when I was selecting and changing this work offset, that my cursor may have changed sometimes, and that's because my snap mode was on. And because my snap mode was on, what was happening, it was actually detecting the snap points directly on my solid. And if I turn off, for example, the solid, you can see that there is no wireframe geometry underneath. So if we click here, you can see if I hover over, for example, here I pick up the endpoint, here I pick up the midpoint, here's another endpoint. So it's making it very easy for me to actually digitize directly on the solid without the need of having to smash that solid. Thanks very much for joining me, and I hope you enjoyed the new enhancements to ESPRIT TNG Release 3.1.